Thanks for joining me again to another one of my mathematics tutorials. In this session, we will be looking at factorizing algebraic expressions. In our last session, we looked at using the distributive law to remove brackets. Let's just quickly review on what was done last session. Let's say I have an expression A multiplied by PQ subtract R. In order to use the distributive law to remove the brackets, what we did, we took A, multiplied it by PQ, and then A multiplied by R. So it became A, PQ, our sign subtract, A multiplied by R gives AR. Now, what factorization is actually the reversal of the process of removing brackets. So what we can do is actually take this expression on the right hand side and use factorization to get back this expression on the left hand side. Now, in order to do that, we need to find the HCF of our terms. So we are starting on the right hand side. So we are taking A, P, Q and AR and we are finding the HCF. A, P, Q is A multiplied by P multiplied by Q and AR is A multiplied by R. Now we are going to extract our common terms. Our common terms are simply A. Now we are going to take that HCF, which is A. So let me write here our HCF is A. We are going to take that and divide throughout that expression by A. So let me just change that pen. It is A, P, Q subtract AR, and I'm going to divide throughout by our HCF A. And what I'm going to get, A is going to cancel with that one and that A is going to cancel with that one there. Now you may be wondering why I can cancel that A twice with those two A's up there. Now let's say I have 8 subtract 6 divided by 2. What we can do this in two ways. We can say 8 subtract 6 to give me 2 and then divide that by 2 and I'm going to get 1. Or I can say that 2 into 8 gives me 4 and that 2 into 6 gives me 3 and I'm going to get 4 subtract 3 is going to give me 1. So that 2 is going to cancel with those two terms at the top there. So I'm dividing throughout by A in my expression here. I'm canceling that A with those two A's and I'm going to be left with P, Q subtract R. So now we can write our HCF, which is A, multiplied by that factor PQ take away R. So PQ take away R. Remember, our aim was to take that expression on the right hand side and get back that expression there that we started off with. So we started with this side here. We found our HCF. Our HCF was A. We divided it throughout by A and that gave us this factor here. So what factorization is, it is actually writing an expression as the product of factors. So one of my factors, which is the HCF A, is here, and another one of the factors was found by dividing throughout by the HCF. So by writing this expression here, this is my new expression here, this here is actually called factorization. taking this right hand side and getting back our expression there with the brackets. So let's have a look at another one. Okay, so in order to factorize this expression, remember firstly we need to find our HCF. So 9b squared and 3b. 9b squared is actually 3 multiplied by 3 multiplied by b multiplied by b, and 3b is 3 multiplied by b. So now we need to circle our common terms. I have 3 being common as well as b. So my HCF is 3b. So what I will do, I'm going to divide throughout my expression by 3b. Now if you look here, after extracting 3b from my first expression, I am left with 3b. So when I divide 9b squared, what I am left with is 3b. And when I divide throughout by 3b in this expression here, what I am left with is 1. 1 is understood to be your remainder there. So it's going to be subtract 1. And this is going to be multiplied by your HCF, which is 3b. Let's see if this factorized expression here gives us back our expression. 3b multiplied by 3b gives 9b squared, and 3b multiplied by 1 gives 3b, and my sign is subtract. So yes, I did get back that original expression there. So my factorized expression is 3b multiplied by 3b take away 1. So let's have a look at another one. 6m to the power 5 n cube p plus 8m to the power 4 n squared p squared. So we are going to factorize this expression. So what we need to do is find our HCF first. So I'm going to write back those two expressions. And I'm going to expand it out so that I can get my HCF. This becomes 2 by 3 by and this one becomes 2 by 4 by good. So to find my HCF, I simply circle my common factors. I have 2b in common. And I have that one there being common. So my HCF is going to be 2 m to the power 4 because I have 4 m's being common there, n squared because I have 2 n's common, p. So it's going to be 2m to the power 4 n squared p, and I'm going to multiply this. Let me write that on another line. So my HCF is that there. And to write my factorized expression, I take my HCF, which is this, and I multiply it by my remainder there. So I get 3mn being my remainder in the first one. And my sign there was plus. My remainder for my second one is 4p. So it's going to be 4p day, and that is your factorized expression. Let's just make sure that when we multiply that out, we get back that. So that is a way to check our answer. So 2m to the power 4 n squared p multiplied by 3mn. 2 by 3 is 6, m to the power 4 by m is m to the power 5, n squared by n cube, and then we have that p, plus 4 by 2 is 8, m to the power 4 n squared p by p gives us m to the power 4 n squared p squared. Yes, so that is actually correct. So there you have it, factorizing algebraic expressions. If you liked this video, please don't forget to like, share, and subscribe for more of my videos.